What is up, guys? Welcome back to another live stream, weekly live stream every Wednesday, where we are tackling Khan Academy problems live. And I'm doing them for the first time, which is super fun. And I am just going to do a quick sound check, make sure everything is going well here. Let's see. Can you guys hear me? Can you guys hear me? I think so. Hold on. Let's see over here. Yes. All right. Oh, let me unmute this. Hold on. Quick sound check. Sound check. Yes. All right. We are good. All right. Let's begin. Now, once again, if you are studying, prepping for the SAT, doing anything math related, and you need help, make sure to subscribe to the channel right now so you can have the most up-to-date information from Scalar Learning on the regular. We got new math music videos coming out regularly, once a month at least. We just had a new one drop on the solving systems of linear equations. Definitely check that out. You get to see me rapping and also singing, and it was really fun to make, so I hope you enjoy that. On top of that, you're going to get the weekly live streams. We're going to start bringing podcasts to you on the YouTube channel, where I'm interviewing all sorts of amazing ed tech companies and talking about education with YouTube stars and also strategies as well. So make sure to check all of that stuff out. The content is only going to be increasing on this channel. All right, let's begin. And today we're tackling radical and rational equations. So let's jump into the practice problems right here. As always, I'm seeing the problems for the first time, which makes it kind of fun. Also, you never know what's going to happen, but you're solving it right along with me. So this is authentic problem solving on the fly. Let's get to it. What is the sum of all the solutions to the above equation? So first of all, we need to find what these solutions are. So we got negative y over y minus 3 minus 6 over y plus 2 equals 1/2. Here's the deal. The first instinct should be in an equation like this, where you see this crazy equation, we got to get rid of these denominators. These denominators are no good. So the way we do it is we find the common denominator amongst all three and multiply across. So let me show you what I'm talking about here. Here what we're talking about is we have a common denominator of y minus 3. Because these have nothing in common, so it's just the common denominator is just simply the product of all three. Boom. And this multiplies everything. Multiplies this, and multiplies this. Now when it jumps over here, imagine what we're going to have is we're going to have a y minus 3 on top and a y minus 3 on the bottom. Here we're going to have a y plus 2 on the top and y plus 2 on the bottom, which will cancel out. And here we'll have, oh, that's meant to be a 2, not a 3. We're going to have a 2 on top and bottom that are going to cancel out. So what do we have left? For this term right here, since the y minus 3's cancel out, we're going to have 2 times y plus 2, and then that negative y that was there from the beginning. We'll put the negative up here. And that's it. The y minus 3 is gone, and that denominator is gone. Minus, now we have 2 times y minus 3, because that stays there here. There's nothing to cancel out with. And the y plus 2 does go away. All right, it's going to cancel out with this guy. And then we still have this 6 here. We can multiply these two in a second. And then equals, on this side, just the 2 cancels out, and we got y minus 3 times y plus 2. You can see this is a pretty difficult question, as these are a higher level type of question, which is why they're so tough. So now we're going to start to factor and or multiply and simplify. So let's go ahead and distribute make life easier. I'm going to make this negative. I'm just going to move the 2y like this, and we can totally do that. It's all multiplying, and then distribute in. We got negative 2y squared minus 4y minus, I'm going to bring the 6 and 2 together and make it 12. And then minus 12y, and the negative times the negative is a positive 36 equals, and then we're going to FOIL. We got y squared. Let me move it over here. Y squared plus 2y minus 3y minus 6. Okay. These guys combine to give us minus 1y minus 6. And what about on this side? We've got negative 2y squared minus 16y plus 36. So pretty brutal equation. Now I'm going to bring everything to the left side, set this equal to 0. So we're going to subtract y squared, add y, and add 6 to get rid of this, this, and this. But we got to do the same here. Subtract y squared, add y, and add 6. And now we got negative 3y squared minus 15y, right? These guys combine to be negative 15y, plus 36 plus 6, which is 42, equals 0. And now, and now we see if we can FOIL this guy, right? We got everything perfect. We could also plug it into the quadratic. The first thing I'm going to do before I factor, make life easier on myself, I'm going to divide everything by 3. Because I can divide both sides by 3. 0 divided by 3 is just 0. That becomes, and I'm going to make it negative 3. Because watch, I can do that. It's okay as long as I divide both sides by negative 3. 0 divided by negative 3, still 0, so we're all good there. Now, let's divide negative 3y squared by negative 3. We get y squared. This one becomes plus 5y, right? 15 divided by 3. And then 42 divided by negative 3 is negative 14. Now, look how nice this is. It's not so bad. It's not too difficult to factor, and we can get our two solutions. We got a y, we got a y. Now, what multiplies to negative 14 adds to 5? It's a positive 7 and a negative 2. Therefore, our solutions are y equals 2 and y equals negative 7, because it's what makes this binomial go to 0, what makes this binomial go to 0. That's a positive 2, negative 7. What is the sum of these two solutions? 2 plus negative 7, negative 5. Brutal problem. Let's see if that's right. Yeah, it's right. And we could have plugged it in and checked it and everything, but doesn't matter. And look at that. Look at all that work. So this is a really hard problem, probably something that you're definitely going to encounter more near the end of a test. And I wouldn't stress too much about something like this in terms of, unless you're trying to score quite high and really nail the test. So that's a long problem. All right, next. What is the sum of all the solutions? Again, we need to follow the same protocol. We need to get this. This is going to be a quadratic function. We need to get it everything set equal to 0 and then factor. So let's start by, we don't like the square root in here, right? How can we factor with the square root? So I am going to get rid of the square root by squaring both sides. That will free these values from the square root, gets rid of the square root. Do the same here. This becomes 5x squared minus 44. Equals, don't just square this term and square this term. We realize that we're actually foiling this binomial. Like this and like this. Like this and like that. So we got 9x squared minus 24x minus 24x plus 64. Plus 64. And that's 9x squared minus 48x, right? I'm combining these guys. Plus 64. Equals 5x squared minus 44. I'm going to, let's bring everything to the right side. How about? So I'm going to subtract 5x squared and add 44. Subtract 5x squared and add 4. Whoops. I could have put it there, but I'm going to put it underneath this exact same thing that we're going to add it to. We're going to be able to add it to the constant. These go away. These go away. 0 equals 9x squared minus 5x squared is 4x squared minus 48x. 64 plus 44 is 108 positive. Divide everything by 4 to make life easy. And we got x squared minus 12x. I could have factored it like this anyways. It doesn't matter, but this is just going to be so much easier. 108 divided by 4 is 27. This is a calculator question, so you could have done calculator if you needed it. And then I'm going to factor this, right? This is equal to 0. Equal to 0. So what multiplies to 27 adds to negative 12? Positive 27, what would be negative 9 and negative 3? Negative 3 times negative 9, positive 27. Negative 9 plus negative 3, negative 12. And therefore my values are x equals 3 and 9, right? 3 makes this guy go to 0, 9 makes this guy go to 0. The sum of these two is 12. All right. Actually, I got lucky there because I didn't check to make sure both of these were good solutions. And in fact, oh no, because it didn't say the sum of all real solutions. So that's all good. Oh no, we did have to check. Oh boy, I got lucky there. So normally what I should have done is I should have plugged in the 3 into this equation and made sure I got a real value. And we have to worry about that because we have a square root here. And if that inside part nets us a negative number within the square root, then it's not a real solution. And we don't include that in the sum. So I actually hastily hit 12. The answer could have just been like 9, for example, if 3 wasn't a good solution. If I plugged it in, it didn't work. And if I got something that was incongruent. So that was lucky. I kind of jumped the gun. And here's where they're checking the answers. You see how they plug 9 in and make sure it worked? Plug 3 in, make sure it worked. So kind of got lucky there. All right, let's go to number 3. And this one I'm definitely going to check and make sure I do it exactly right. So look, product of all solutions to the equation above. Get rid of the square roots. Easy. Square both sides. 6r equals r squared minus 16. Subtract 6r. Subtract 6r. Then we got r squared minus 6r minus 16 equals 0. 0 equals, and I'm going to factor this guy, right? R, what multiplies to negative 16 adds to negative 6. I'm going to say that is negative 8 and positive 2. So my solutions for R are what makes this go to 0, negative 2. What makes this go to 0, positive 8. Before I multiply these, let's check them. So let's try negative 2 first. Square root of 6 times negative 2, right, equals square root of negative 2 squared minus 16. This becomes square root of negative 12. This becomes square root of 4 minus 16, which is square root of negative 12 equals square root of negative 12. So this actually works, even though we're getting imaginary numbers, but it works. Okay, next let's try 8, and we got square root of 6 times 8 equals square root of 8 squared, which is 64, minus 16. This becomes square root of 48. This becomes square root of 48. I believe this also works. This makes me a little wary because I haven't seen this before where actually it worked. We get this negative on both sides. These two solutions should be good. Let's try it out. Product of those two solutions, negative 2 times negative 8, which is negative 16. Let's see if this works or if this gives me a problem. No, it's incorrect. So that negative 2 should have been invalidated, and let's see their explanation as to why. Because we get a negative 12. All right. So they're calling this an extraneous solution because it in fact gives us a negative square root, which is usually a warning sign, but I thought maybe because it was a negative 12 equals a negative 12, we'd still count it. And so that's why it's thrown out. In this case, the product, we just have one solution, and it's 8. So I got that incorrect, and that's my mistake. All right, let's move on to question number 4. All right, here we go. What is the sum of all solutions? Same idea. I'm going to square both sides to get rid of this square root. Squared. We got w squared equals 108w. All right. Now, this one's not going to be so bad because I can just, well, I can do one of two things. I can move this over. Subtract 108w from both sides. Subtract 108w from both sides. We get w squared minus 108w equals 0. Then I can factor it out like this. W minus 108, right, equals 0. And I got two solutions for w. I got 0. And I got, because that's going to make, if w is 0, it'll make this whole thing go to 0. If w is also 108, going to make this go to 0. These are my two solutions. Let's just double check them really quickly. W equals square root of 108w. So if w equals 0 and plug in 0 here, it'll be 0 equals 0. That works. If w equals 108, we have 108 equals square root of 108 times 108, which in fact is 108, right? This is just 108 squared. Both of these solutions work. The sum of these two solutions is 108 plus 0, which is 108. Pretty much should be right, and it is. All right, good. Let's go finally to question number 5. 3x plus 7 square root equals x plus 1. And we're going to do the same idea. Square both sides to get rid of that square root first. We now get 3x plus 7 equals x plus 1 times x plus 1. Now let's FOIL this guy. And we get x squared plus x plus 1, which is x squared plus 2x plus 1. equals 3x plus 7. Now I'm going to subtract 3x from both sides, and I'm going to subtract 7 from both sides, and we get 0 equals x squared minus x minus 6. Now let's factor this guy. We get x and x. Now what multiplies to negative 6 adds to negative 1. We got a negative 3 and a positive 2. And then for our two solutions, we get x equals negative 2, x equals positive 3. All right. So the sum of these solutions, we could add them together. But first, not going to make that same mistake. We're going to check these answers and make sure they're good. Actually, wait. Let me undo that. Okay. So the way we're going to check is we're going to go back to the original equation. All right. And we're going to plug in these two values. First, negative 2. So if I plug in negative 2 here, I get negative 6, right? 3 times negative 2 is negative 6 plus 7. Square root of 1, which is 1. Here, I plug in negative 2, which I get negative 2 plus 1 equals negative 1. These guys are not equal. So negative 2 is out. Oops, it looks like I crossed off negative 3. So negative 2 is out. What about 3? So we get 3 times 3 plus 7, which is 9 plus 7, which is 16. Square root of 16, which is 4. On the left side, what about the right side? We got 3 plus 1, which is 4. These guys are equal, and boom. So the only good solution here is 3. Good thing I checked, and that is good. They go through the same process. And that's that. All right, thank you guys for joining for the weekly live stream solving Khan Academy SAT problems. Sorry it was so late today. It's just been a crazy day, a lot of tutoring. School was nuts, and it had to be at this time, but I got it in, and I hope you guys enjoyed it. If you guys have any questions, please leave the questions in the comments. If you guys would like to see me solve specific problems, let me know again in the comments. And if you haven't done so yet, make sure to subscribe to the channel so you can get weekly live streams sent to you via me, as well as get all the updates and notifications on the math music videos and other projects that I'm working on the regular. Thank you guys so much for joining, and I'll see you guys next time. Take it easy.